So how do we keep our buildings smart and healthy? Right now, we're looking at two totally different playbooks. Do we rig the whole place with an army of tiny, stationary spies, or do we hire a single, roving, robotic detective to patrol the halls? Let's get into this high-tech showdown and see which one really comes out on top.
And that's really the core question, isn't it? If you're managing a modern building, this is the choice you face. Do you bet on a huge network of fixed sensors constantly watching from the walls? Or is one single, smart robot the better way to keep an eye on things?
At the end of the day, it all boils down to this. We want our buildings to be healthy places to be, and we want them to be efficient. The real question is, which of these technologies gives us the best bang for our buck, not just today, but for decades to come?
Okay, so first things first, why are we even talking about this? I mean, why do our buildings need this kind of intense monitoring in the first place?
Well, it all starts with this one kind of shocking number. On average, we spend 90% of our entire lives indoors. Think about that. Our offices, our homes, schools, that's where we live.
And if the air quality in those spaces is bad or the temperature is off, it does more than just make us a little uncomfortable. No, the science is clear. It actually hurts our health, it kills our productivity, and it can literally make us dumber. So yeah, monitoring our indoor environment isn't some luxury. It's absolutely essential.
All right, so we get the problem. Now let's meet the two high-tech solutions that are duking it out to solve it. Time to meet our spies and our detective.
So here's the tale of the tape. In one corner, you have the spies. Hundreds, maybe thousands of fixed sensors. They give you constant data from one spot, but wow, installing them is a massive job. And if you ever change the building's layout, it's a total nightmare. In the other corner, you've got the detective, one mobile robot. It completely skips that installation headache, it can go wherever you need it to, and it adapts to changes in a snap. It's really a battle of being everywhere at once versus being anywhere you need.
So how do you pick a winner? Well, it's not about the sticker price you see on day one. To get the real answer, you have to look at the total cost over the entire life of the system.
And the tool for that is something called a life cycle cost analysis, or LCCA. It's a really powerful idea. It forces you to think about the long game by adding up every single cost from the day you buy it to the day you finally get rid of it.
Here's how it works. First, you've got your initial costs, buying the gear and getting it installed. Then you have all the ongoing costs for operations and maintenance, stuff like electricity, repairs, and paying people to manage it. You also have to plan for replacing equipment when it wears out. And finally, you even factor in what you might get back if you resell it at the very end. It gives you the whole story, financially speaking.
Okay, enough with the setup. Let's get to the juicy part, the results. Researchers ran this exact analysis on commercial buildings in Mumbai, India, looking at all the costs over a 50-year lifespan. And what they found was that size really matters. Now, for a pretty small commercial building, let's say around 60,000 square feet, the answer is not even close. The army of fixed sensors is dramatically cheaper over 50 years. I mean, the total cost is less than half of what the mobile robot system would run you.
To put a hard number on it, the total lifetime cost for that fixed sensor network is about 35 million Indian rupees. In a smaller space, it is a knockout victory for the spies.
But, and this is a big but, watch what happens when we scale up to a large building, around 250,000 square feet. The whole thing flips on its head. All of a sudden, that single robotic detective becomes the more cost-effective choice. Its lifetime cost actually drops well below the sensors. Why? Because in a huge space, the cost of installing and maintaining that massive army of spies just gets out of control.
So, case closed, right? Small buildings get sensors. Big buildings get robots. Well, not so fast. The analysis found another crucial factor, a wild card that can change the game completely.
Turns out it's not just about how big the space is, it's about how often you need to collect data. Think about it. If you need a constant, up-to-the-second stream of information, that's one thing. But what if you only need a checkup every 15 minutes? That changes the entire calculation.
Let's look at a mid-sized building. If you need data every 5 minutes, the fixed sensors are still cheaper. But if you can stretch that out to every 15 minutes, boom, the mobile robot wins on cost. The reason's pretty simple. A single robot can easily do its rounds and cover the whole building in that time, which means its costs are much lower. This is that economic break-even point in action.
So, let's just wrap this all up with the key takeaways. 1. For smaller buildings, that fixed sensor network is probably your most economical bet. 2. For larger buildings, the robotic detective often wins the long-term cost battle.
But 3, and this is the most important part, there is no single best answer. It always depends on your specific needs, the size of your building and how frequently you need that data, and finally, always think in terms of lifetime cost, not just the price tag.
All of this leaves us with a pretty cool final thought. We're heading toward a future where our buildings are almost like living, breathing organisms, constantly checking on their own health. So the question is, what kind of nervous system are we going to give them? Will it be a diffuse network embedded in every wall, or will it be a central, mobile intelligence roaming the halls? The answer is still being built.